So I'm Dr. Lutzmiri, Associate Professor in the Department of Computer Science and Engineering in Rohini College of Technology. So I'm going to take the topic from the subject operating system. The subject code is CS8493, which is for the second year CC students in 4th semester. Subjectives is describe the physical structure of secondary and tertiary storage devices and the resulting effects on the use of the devices. Explain the performance characteristics of mass storage. So disk scheduling, the operating system is responsible for using hardware efficiently. For the disk drives, this means a fast access and disk bandwidth. Access time will be having seek time and rotational latency. So seek time is the time for the disk to move the heads to the cylinder containing the desired sector. Rotational latency is additional time waiting for the disk to rotate the desired sector to the disk head. So minimize the seek time. Seek time is approximated to seek distance. The disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. So several algorithms exist to schedule the servicing of disk IO request. So request queue will be having 98, so the data is given, the head pointer will be 53. So first come first serve shows the head moment of 640 cylinders. Head starts at 50. SSTS shortest time first. So it selects a request the minimum seek time with from the current head position. SSTF scheduling is a form of SJF, shortest job first scheduling. It may cause starvation of some request. Illustration shows a total head moment of 236 cylinders. Scan. The disk arm starts at one end of the disk and moves towards the other end, servicing the request until it gets to the other end of the disk where the head moment is reversed and the servicing continues. Sometimes it is called as elevator algorithm. So the illustration shows the total head moment of 8 cylinders. The same data along with the scan algorithm. C scan. So you can have it's a more waiting time, so more uniform waiting time than scan. It head moves from one end of the disk to the other. Service a request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. Treats the cylinder as a circular list that wraps around from the last cylinder to the next one. So there is an example with C look. It's a version of the C scan. Arm only goes as far as the last request in each direction, then reverses the direction immediately without first going all the way to the end of the disk. So the same thing along with the selecting a disk scheduling algorithm. SSTF is a common and is natural. C-scan and scan's better performance, the heavy load. Performance depends upon the number and types of request. Request for disk service can be influenced by the file allocation. This type of service can be used by the file allocation method. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. So the default algorithm is SSTF or LOOK. So disk management, low level formatting or physical formatting, dividing the disk into sectors that the disk controller can read and write. To use the disk to hold files, the operating system still needs to record its own data structure on the disk. Partition the disk into one or more groups of cylinders, allow logical formatting or marking a file system. Boot block initializes system. The bootstrap is stored in the ROM. The bootstrap loader program. Methods such as sector sparing used to handle bad blocks. Swap space management. Its virtual memory uses disk space as an extension of main memory. Swap space can be carved out of the normal file system. It can be in a separate disk partition. Swap space management 4.3 Berkeley State data allocates and swap management. When the process starts, it holds the program and data segment. It uses swap maps to track swap space use. Solaris is to allocate swap space only when the page is forced out of physical memory. Data structures for swapping on Linux system. So the swap map will be having 10301. Swap area is shown. The swap partition or swap file inside the page. Within that, the slot is given. RAID structure. RAID multiple disk drives provides reliability via redundancy. RAID is arranged into 6 different levels. So RAID has several Improvements in disk use techniques involves the use of multiple disk working cooperatively. So stripping is there. So RAID improves the performance reliability of the storage system by storing redundant data. So the famous one is known as mirroring. It keeps duplicate on each disk. Block interleaved parity uses much less latency. Various levels 0, 1, 2, 3, 4, 5 are there. 0 plus 1 and 1 and 1 plus 0, the mirroring. Stable storage representation implementation. A write ahead log scheme is used instead of stable. To implement the stable storage, you have to replicate the information on more than one volatile storage. So update information in a controlled manner to ensure that we can recover the stable data after any. Tertiary storage devices low cost. Generally, it's used with the removable media. So examples are floppy disk and CD-RAMs. Other available or warm disk. The data on a read-write disk can be modified over and over. So write once and read many times can be used written once. The aluminum film sandwiched between two glasses or plastic plate. To write a bit, the drive uses a laser light to burn a small hole on the aluminum. Information can be destroyed by not altered. Very durable and reliable read-only disk such as CD-ROM and DVD. It's the data loaded. Tapes. Tape is less expensive and holds much more data, but random access is much slower. Tape is an economical medium for purposes that do not require fast access. A backup copies disk data holding voluminous data. So stacker and silo, the slots used is library that holds a few tapes. Silo is a library that holds thousands of tapes. Possible questions. So compare the functionalities of FCFS, SSTF, C-scan and C lookup with the example. Explain about RAID in detail. Thank you. Thanks for your patience.